Welcome to the number of cavities calculation video guide. My name is Tim, and I'm one of the thermoforming.tech founders. Thermoforming.tech team creates tools to simplify your launching of new thermoforming projects. Sooner or later, anyone who wants to start thermoforming production finds out that the number of cavities on the mold is the starting point in any project calculation. In our thermoforming productivity video guide, we explain how many machine hours can you get from your thermoformer and how to calculate minimum productivity per one machine hour. This video guide will show you what affects the number of cavities on the mold and how to calculate it. The number of cavities is affected by two groups of parameters. Forming area related parameters affect how many cavities can fit in the forming area. For example, this machine has forming area 840 by 570, and we can place cavities till we reach the limit. We'll stop here for the moment. Every thermoformer has a limitation for the mold size. It is affected by multiple parameters, including the beam size, chain spreading, columns distance. You can never use 100% of the mold for forming. You always need some additional space. So here, for example, the maximum mold size is 870 by 600. The second group of the parameters is the cutting force of the machine. How much pressure can machine apply when closing beams in the mold? It affects how many cavities can machine cut out from the sheet. So every time we calculate the number of cavities, we have to check how many products we can physically place on the mold and how many products can machine cut out from the sheet. Now let's take a deeper look at each of those aspects. If your background does not allow you to make all the calculation by yourself, there are three ways how you can proceed. You can make a simple preliminary number of cavities calculation by yourself, and we will show you how. Or there is a standard way to contact your supplier and ask for tool layout calculation. In this case, you will get all the parameters for the project, and this is the common way for how we do it for many years. Or there is another way you can use our platform and get the same calculation done by yourself with more parameters and much faster. Now let's take a deeper look at each of three ways. Number of cavities estimation by yourself is pretty straightforward. All that you need to know is the forming area and the product dimensions. Keep in mind two things. Forming area is always less than the mold size, and you need to add about 13 millimeters between the cavities, unless it is a shared edge tooling. Let's check on the example. Let's say our product is 160 by 120, and the forming area is 750 by 530. In this case, if we want to place 5 cavities, we will need 800 millimeters, which is clearly more than 750. And if we want to put 4 cavities, we have 640. Then we need to add some space between the cavities, and we have 679 millimeters, which fits our forming area. On the other side, we have 120, and we multiply by 5 with 600, which is above the forming area. If we use 4, then we have 480 and another 39 millimeters between the cavities, 519, which is clearly okay and it fits on the forming area. So we have 4x4 tool configuration, which gives us 16 cavities. The next step is to make reverse calculation 120 by 160. Sometimes it gives us more, sometimes less. Well, you can do it by yourself, and you will find out that the maximum number of cavities in this case will be 15, 5 by 3. So our forming area allows us to place 16 cavities. Be careful with on-the-limit values. Additional parameters like material shrinkage also affect the forming area usage. If you have at least 10 millimeters in each direction, it is okay. If the value is less or exactly on the limit, you either have to contact your supplier or to use another way or to reduce the number of cavities. The second way is to contact your supplier. It can be either a machine supplier or your mold maker. In this case, you send all the details about your product and the machine, and after some time, usually it takes 2 to 5 days, your supplier gives the answer. For example, this is how the tool layout can look like. To make supplier's answer efficient, do not request only the number of cavities, but get a tool layout that provides all necessary information the number of cavities on the mold, width of the material which you will need, tool efficiency, and percentage, which tells you how much waste you will get from your 1 kilogram of your material. Also, you can request for a cycle speed estimation. To get those answers, you must provide the supplier with the following information: the dimensions of your product, including all heights if there is more than one, the weight of or material thickness for each size of the product, the material type, and the best will be if you provide the drawings or at least photos of the product. Sometimes, supplier's request is not the best option. For example, if your supplier makes the same preliminary calculation as described above to act fast, in this case the final values can change to a higher and lower amounts. Ensure that supplier worked on the project intensely. The second thing, if you want to compare two suppliers, you have to ask for the answer from each of them, and you have to wait for a longer time till you synchronize and get both replies. If there is more than one product for calculation and the contract is not finalized and signed, the waiting time can last really long, because multiple requests for non-confirmed projects usually get lower priority. You can save a lot of time on our platform when you estimate number of cavities on the forming area. Let's open it and study how it calculates the number of cavities. And you choose a machine, the mold size and forming area is already here, and then you set the product dimensions and add number of rows and columns until you reach the limit. The system will inform you if you're out of the limit and you're not available of adding more cavities. You can also play with the shared edge tooling if you know why and what you're doing, or you can modify the columns distance. As you can see, the forming area, which is calculated, is very close to our estimation which we did before in Excel. As we have already discussed, the number of cavities on the mold relies not only on the forming area, but also on machine cutting capacity. The cutting capacity is complicated and it's really hard to explain because this information is usually not discussed with the customers by the machine suppliers. The machine applies closing force on its beams to match the upper and bottom mold. The closing force is recalculated in the linear knife length of your products for both forming and cutting, and there are multiple variables in this formula. Material thickness. A thicker sheet you use, the more force you have to apply to cut your product. The cutting die temperature. The hot die decreases the force that has to be applied as it melts the material. Remember that the heating dies is used mostly in form cut stack tooling, while in mold cut usually uses cold die. The dimensions of your product also affect. The more extended perimeter you have, the more force has to be applied. And the number of cavities on the mold. Each cavity multiplies the required linear knife length by the perimeter of the product. Those are essential parameters, but there are a couple of more which we don't even want to go that deep. The cutting capacity calculation becomes a problem if you don't know the form. Most equipment suppliers don't share their information on the cutting capacity formula. The only parameter that is public is machine tonnage. It allows to compare machines, and it is clear that 80 tons machine has higher cutting capacity than a 60-ton machine. The cutting capacity calculation can become a problem. For this reason, suppliers provide cutting graphs, like this one here. It shows for each material and each tool configuration the maximum linear knife length based on material thickness. You can request the cutting graph from your supplier for your machine configuration and your material. Or there is another way to use our platform. In cooperation with the machine suppliers, mold makers, and thermoforming packaging suppliers, our team adds the equipment to our database. You can use our platform to check the cutting capacity for the equipment added to the database. For each machine, there can be information, only forming area, and no cutting data. It means that you can check the forming area, but you cannot check the cutting capacity. Or machine can be added by a user, and in this case, information is not confirmed by the supplier. It can wait for supplier's confirmation, or it can be approved by supplier. It means that supplier confirms the cutting data and the forming area, and you can rely on it with 100%. Keep in mind that we aggregate the information from the market and make the automation. We do not take any responsibility for the cutting capacity of the equipment in our database. Now let's go through the process step by step. Let's get back to our platform and check the number of cavities there. As we discussed, the cutting capacity relies on material type and thickness. For GNN 760 for polypropylene of 355 microns, the maximum cutting capacity is 11.5 meters. It is on the left column. On the right column, you see the calculated linear knife length for the existing number of cavities. If we change the number of cavities, the linear knife length of the tool changes. If we change the material, it also changes here. Or if we change the thickness and set it to 500, we have a new value for the maximum linear knife. If we will switch to another machine and we will set the form cut stack tooling with the heated dies, you can see that the linear knife length changes dramatically. And now we can use PT with no problem. We can even increase to 700 microns, and we are still within the limit. By getting information from our suppliers and adding them to the database, we allow you to make the cavity calculation based on the forming area of the equipment and on the cutting capacity of the machines which are added to the database. This video guide has come to an end, and now you have 3 ways of cavity number calculation. With this information, the productivity and output of your equipment can be calculated. This information is not enough to choose the equipment, but it allows you to understand thermoforming equipment better, and that's a good start. Check our other videos and tutorials for more information, and you can try our thermoforming.tech software that allows you not only to calculate the tool layouts, but also to make a fast project economy calculation and compare multiple options with the experts of data to PDF or Microsoft Excel. Thank you for your time.